Okay, so okay, take your time to settle down, no worries. Right? So I think in the last lesson, right, we completed this question, right? I wrote out the full solution, okay, and proved that it's zero. Alright, so we have done graph of a two variable function, right? We also done limits of multivariable function, right? And then we went through partial derivative, right? The geometrical aspect of it, what are you actually doing when you're doing partial derivative? And then we also link back to single variable calculus, right? So there are two small sections, all right, which I can finish in about 10 to 12 minutes, all right? Partial differentiation of implicit functions, right? And then total differential, right? And after that, we will start a new topic again, okay? Not say start a new topic. We will go into some applications, okay? Okay. All right. So implicit function, okay? I believe all of you have seen it before, right? You should have seen it before and heard of it, right? Sometimes the explicit form of z equal to fxy is not available, right? Very seldom I write z equal to something nicely for you. Okay, I will deliberately embed it. Okay, all the terms are mixed together, right? Okay, but right, so that's what we mean by defined by an implicit equation. So you have a big function f, inside is a mixture of x, y, z equal to c. Alright? So whatever question I give to you, you try to make it into this form, right? Where it's equal to c, a constant. Okay? So, for example, this I give an example over there. Right? You have a f equal to x squared plus y squared plus z squared equal to 1. Okay, it's a unit sphere, right? We went through this in the last lesson, right? Okay, so I may not be so nice, right, to give you beautifully like this, z equal to plus minus square root of 1 minus x squared minus y squared. Sometimes it's too difficult, too much effort, right, to make z the subject, right? So sometimes it's mixture like this, x squared plus y squared plus z squared equal to 1. Okay, so how do you find zx and zy? That means del z del x and del z del y. How do you do that? Alright? Okay, so this is our question. Del z del x, how to find? Del z del y, how to find? Right? This is our question for today. Right? Okay, so you have this big F, right, is in terms of your x, y, z, right? But now you want to find the relationship, del z, del x, right? Okay, so the approach is that you decompose big F as x equal to x, y equal to y, and z equal to zxy. Okay, it seems a bit abstract, okay, but later I use the actual example, it will be very clear. Alright, because math always, I don't want to just show you the formula and then the approach, the method lah, right? I want to go through the idea behind it, right? How does all this formula come about? Okay, because some students learn better that way. I would say that 50%, right, learn better that way, right? If there's some motivation, some background of how all these equations come about, right? Of course, the other 50% is don't want to care about all these things, just want to learn the formula, learn how to apply the formula. Okay, I leave it to you lah. There's no hard and fast rule. Okay, there's no hard and fast rule. Right? Okay, implicit function differentiation rule. Alright. Okay, take partial derivative on both sides of big F equal to c. Okay, right, and at the same time use the chain rule. Right, so equation number 2 seems very friendly, right? Very mild, very friendly, very approachable, you know. But behind the scene, there's a lot of steps involved, okay, which I will demonstrate in a very short while. All right, okay, right, and then over here, right, these are the workings, but ultimately is to build up and give us equation number 4. The formula for del z, del x, and the formula for del z, del y. Starting from big F in terms of x, y, z equal to a c constant. Alright? Okay, so the derivation is as follow. Okay, the derivation is as follow. Okay, your z, right, your z, okay, your z equal to fxy, right? Let a surface z equal to fxy, right, be implicitly defined by the equation below. Okay, so this is what we call a surface lah, because it's for the f function. Okay, your input is x and y. It gives you a z value, so it's like a surface. Okay, all right. Okay, and we have this is the original question. All right. Okay, and your z is your fxy actually, right? So, like I said already, our objective is to find out what is del z, del x, and del z, del y using the chain rule. Okay, but first thing first, there are some basic that I need you to remember. Your z equal to fxy. Okay, it means that your independent variables are x and y. Okay, they do not depend on each other. They are the inputs. They do not depend on each other. Right? Okay. So now you go and implicitly differentiate the original questions here. Okay. You go and implicitly go and differentiate this guy here. All right. Okay. So I hope everyone is with me, right? The big F, okay? Okay, right hand side is the easiest lah. You differentiate, okay? We start off with x first, okay? Partial differentiate with respect to x first, implicit differentiation. You differentiate with respect to a constant c, of course you get 0. Right? Your big F, okay? Your big F, okay? This is how, what we went through last week, right? Del f, del x, del f, del x, del f, del x. Okay, you write this way. Okay, but inside as x, y, z. So you top up with del x, del x, del y, del y, del z, del z. Okay, that is the faster way lah. Alright? Okay, basically that's chain rule ma. The whole idea about chain rule. You need to invoke everybody inside the inner. Right? Okay, so this is the idea. Okay? Right? But in actual fact, okay, intuitively it's like that. Loosely speaking, right? The del x can cancel, del x, del y cancel, del z cancel. So you are basically looking at the del f, del x, okay, with contribution from the x. Del f, del x with contribution from the y. Del f, del x with contribution from the z. Alright? Okay? Then after that, okay, del f, del x you cannot simplify further. Del x is 1. Del y, del x is 0. Y and x independent, no relationship. Okay, so this term here is 0. So the whole term becomes 0. Alright, and then this one you just copy it down. Okay, what we are interested in is there already. Right, we are interested in del z, del x. Okay, you just make some effort. Okay, bring him over. Okay, make him the subject. You will get negative del f, del x over del f, del z. Alright? And this is what we have. This is what we have. Here. Okay? Alright? Do the same thing with respect to y. Okay? Do the same thing with respect to y. Alright? Okay, I will upload all this, so don't worry. Alright? Okay, so you do a partial, you do a del f, del y, and as well on the right hand side as well. Okay, right hand side is 0 lah. Just copy down 0. Okay, and then you write out this most important line here. Okay, this most important line is your main job. All right. Okay. Okay. So del F, del Y, del F, del Y, del F, del Y. Okay, but inside is X, Y, Z. So you need to analyze each contribution. So del X, del X, del Y, del Y, del Z, del Z. All right. Technically speaking, you cannot cancel like that one, term by term. It's a part, it's a component, 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 it's a component. Right? But for quick, application of the formula, usually this is the trick we always use. You are looking at del F, del Y, okay, del F, del Y, del F, del Y, del F, del Y. Then you insert the individual component. Okay, del X, del Y is 0. X and Y, no relationship. Del Y is 1, straightforward. The rest, you simplify. Okay, and then the same thing, okay, you find the del F, del Y, okay, what we are interested in, okay, you get negative Fy over Fz. Alright, okay, so let's go back and double confirm, okay, this formula here. Alright, okay, is over here. Right? Same. Okay? That's how the derivation comes about. Okay? Alright? So now we go through one example. Alright? Now we go through one example. Okay? Now, so this is the type of question I will give you. Okay? Suppose that z is a function of x and y, defined implicitly by the equation below. Find your zx and zy. Okay? Zx and zy. Alright? Okay. There are two methods I can do. Okay? One method is that, okay, you have been a very good student, alright? You remember all the things I tell you, alright? You remember all the formulas. Okay, so you see that this is in the form, right? Big F equal to x cubed plus y cubed plus z cubed plus 6xyz is a function involving xyz, right? Okay, so you just carry out the partial differentiation with respect to x. All right, you get this. Partial differentiation with respect to y, you get this. Partial differentiate with respect to z, you get this. Alright? And then you use the formula number 4, which I just derived for you. Okay? You can go and sub it in. You will get this is your del z, del x. This is your del z, del y. Just pure sub in. That's it. Okay? No thinking involved. Alright? But imagine, okay, you didn't remember any formula. You can always work from first principle. Okay, work on first principle. Whatever I show you in the derivation of the proof, right, you can apply the same methodology, right, to solve this question. Alright, okay. The right hand side is equal to 1, right? So when you differentiate, it's 0. So I didn't write it down. Okay, it's equal to 0 anyway. I didn't. Okay, doesn't matter lah, because the most important is that here is the right. You write it in this form. Okay, the big F here. Okay, you do the differentiation, partial differentiation, and then you sub it in accordingly. Right, that's the most important. Okay, now let me go through the first principle. Let me go through the first principle. Right. So first thing first, you identify that this is your big F, X, Y, Z. Okay? You have to identify that. Alright? So let's say I want to do del Z, del X. Okay? So del Z, del X. Okay? Partial differentiate respect to X. Right? X cubed plus Y cubed plus Z cubed plus 6xyz. Alright? Okay? And this give me differentiation partial differentiate with respect 1, of course that is equal to 0. Alright? Now, you just apply your chain rule, okay, implicit differentiation from your single variable calculus. Okay, so this is what you will get, 3x squared. Right, you differentiate x cubed, you get 3x squared. Differentiate y cubed, of course you get you differentiate y cubed with respect to x. You get I got to rewind and teach the past 15 minutes. I got to go back all over again. You differentiate y cubed, partial differentiate y cubed respect to x, you get 0, right? Okay. And then z cubed will be 3z squared del z del x. Okay, chain rule, single variable. This one is not new, it's not a new concept. Single variable, right? Y cubed, you proceed to differentiate him as per normal, you get z cubed. You go and proceed to differentiate him, you get 3z squared. But inside the z, they may be component of x, so you do a del z del x chain rule. Alright? And then you plus, wow, this part here is tough. 6x. Okay, 6xyz. Okay. The 6 is just a coefficient. Don't make it distract you. Right? This one you have to use product rule. Okay? So x is one term, yz is one term. The 6 is a coefficient, always there one. Let's not confuse with that guy. Alright? Okay? So product rule. Alright? How do you do product rule? Product rule, you copy down the first term, right? Differentiate yz. Alright? Differentiate yz with respect to x. Okay? Respect to x. Your y is a constant, right? When you differentiate respect to x. But your z has component of x inside, so del z del x. Alright? Don't forget the 6 that is always there, right? Because it's a 6 that's in the beginning already. Alright? Then you plus another 6. Alright? And then you copy down the second term of the product rule. Right? So you get yz. And then you differentiate the other term. You differentiate x with respect to x. You get 1. Okay, this kind of thing you must do quickly. You don't do quickly together in a line, you lost your train of thought. Alright? So just now I was writing and talking, wow, it's not easy. Okay, product rule, basically product rule. Alright? And then you just simplify. 3x squared plus 3z squared del z del x. Alright? And then you have plus 6xy del z del x. Okay? And then you plus 6yz equal to 0. Okay? So my next step will be to divide throughout by 3 lah. Simple arithmetic. We divide throughout by 3. So x squared plus z squared del z del x plus 6xy divided by 3 will become 2xy del z del x plus 2yz equal to 0. Now your job is to make, del z del x the subject, del z del x the subject. Okay, I do some mental calculation. This one is high school algebraic manipulation. Alright. Okay, so you make del z del x the, you make del z del x, the subject, and then you will get negative here, x squared plus 2yz, right? Yes, 2yz divided by z squared plus 2xy. It's the same answer lah, huh? Must be the same answer. Wow. Hopefully, I didn't make any careless mistake. Okay. Right. So del z del x is negative x squared plus 2yz over z squared. Yes. Okay. I clap for myself. Okay. Okay, it's correct. Okay. Must be the same answer. One is by first principle. One is direct formula application. Okay. Direct formula application. Okay. Okay, good. Right, so let's move on. Right. Oh, so for the del z, del y, I leave it to you as an exercise. Okay, you can go and practice by first principle. Right, just in case the exam you forget formula. Right, you can use this by first principle approach. All right. Next, I will move on to a mini section called total differential. All right, called total differential. Right, this is a concept that is always taught in single variable calculus already. Alright, total differential used for approximation. Alright, total differential. Right. So I think the total differential, right? The main concept is like this lah. Okay, the main concept is like this. Right. We have y prime is your dy dx. Right. So for approximation. Okay, for approximation, right, our dy is equal to f prime x times dx. Okay, right? Okay, so this is an approximation. For the let's say for a small change, okay, you move x. Okay, you are okay in a single variable world. You move a small dx. What is the change in your y corresponding y? Okay, will be your f prime times your dx. Okay, right? This is very. I think they must have done a good job in a single variable because this is the key concept, right? In single variable calculus. Okay. Now we have the same thing, right? I want to extend this to the multivariable world. All right, we want to extend this to the multivariable world. Great. Suppose that you have a continuous function fxy in some region, and both del f del x and del f del y are continuous in that region. The total differential of z equal to fxy at any point x comma y is, right? So now, all right, we have, imagine you are at a point x comma y. Okay, imagine you are at a point x comma y. All right. Doing this total differential, all right, tell you how much the value of the function changes as one move, okay, infinitesimal amounts dx and dy in the x and y direction. Okay, dx and dy is smaller, small steps, all right, small steps, okay, right, infinitesimal amount dx and dy, small steps, right. So imagine you are here, okay. So in the multivariable calculus world, you don't just walk in a line x and y. X only. Just okay. You are now can move x and y. So imagine here, from here you move to here. Right. From here you move to here. Right. Okay. So let's investigate. When you move like this, all right, you move a small x. Okay. Your functional value, right. Okay, this small red color changes is del f del x times dx. This one is from the single variable formula one. Okay, nothing new. We did not teach anything new. It's the same as what we have done. You have done in single variable. Okay. Then you also move along the y direction, a small dy. So from here you move to here. All right. Small dy. Alright, okay. For this small dy, for this change in f, alright, okay, this part here, right, okay, it will be del f del y times dy. Okay, it's similar to the single variable world, right? But that one is only x, but now you got y, so you change the x to y, change the x to y, so it's del f del y dy. Alright, okay, so this part is the bottom, increase. Right? When you move here, you increase something a bit already. Right? Then you move in the y direction, you incremental a little bit more. So the total effect, okay, the change in your f is del f del x times dx plus del f del y times dy. Nothing lah. Okay, it's your single variable. Now got one more component coming up only. Okay, nothing much. Okay, don't worry so much. All right, don't worry so much. Okay. Okay, so find the total differential of f, okay, given in this. All right. So far in the quiz and exam, I have not set total differential before. Okay, this one quite insulting to you, right? If I said just apply formula, nothing, right? Just apply formula. Okay, right? So this is the question. Huh? Okay, okay, I give the f, right? Okay, your job is just to find the fx and fy only. All right, your job is find the fx and fy only, right? Fx is your del f del x, fy is your del f del y. Okay, you do your partial differentiation. By right now, you should be more expertly than me in doing partial differentiation. Okay, right? Because you do the tutorial 20 questions already. All right, partial differentiation. Now you should be expertly ready. All right. Okay, you do your simplification, right? Then you sub inside the formula. Okay, sub inside the formula. All right. So the question or your engineering problem, okay, will tell you that dx is 1 unit. Okay, dy is 2 units. Okay, then you sub in accordingly, Okay, and then based on the position you are at, x and y, you sub in all this accordingly. Then you will get the df. Right, this is a very quick and dirty lah. We call this the quick and dirty approximation, right? Of the, if it's a very small dx and small dy, right? Sometimes it's in engineering world we use this kind of approximation because we want quick and dirty, right? If you make some adjustment, what we call the sensitivity analysis, right? So we use this kind of local approximation, right? To have a sense, is it still within the limits of certain machine or certain chemical, how it's work, etc. Okay, that's it, right? I didn't go through this last few slides last week because I think you done a good job, right? And the content was quite messy, so I think I stopped there, right? So this is what we have done last week and this afternoon, right? We have done until here. Okay, good. So now we are on target, okay, to start another section. All right, okay. This is called the multiple integral, right? So in a way, this is an application, okay, of your partial derivative. All right, okay, it's an application. All right, okay, multiple integral. All right, so I just give you a quick overview, right, of why you are learning all these things. All right, okay, and then in the tutorial, I also deliberately infuse in some applications. All right, okay. So by the end of this part here, you will be able to evaluate double integral on general regions, okay, x type, y type domain. All right, and by changing order of integration, okay, compute double integral in polar, right? And then the application of all this is that we apply multiple integral to find area, mass, okay, volume, etc., right? Mass, moment of inertia, etc., right? Because in the real world, the shape you are looking at, the object you are looking at is multivariable and is of some very complex shape. There is no fixed formula. There is no easy formula that you can just, volume of cone, volume of sphere, that kind of thing, right? All the shapes in the real world, usually you have to go and use your double integration. Okay, of course, there is also triple integration later on. All right, it has other application, but now we focus on double integration first. Okay, do it well. Okay, do it good, do it well. All right. Now I will be very happy if I can finish point number 1. Okay, last semester I spent 2.5 hours to teach item number 1. Okay, because a lot of theory, a lot of explanation, right? So this time round, I want to do something different. Okay, I don't know whether we don't do too much theory and the explanation of the formula. I will still do it, but I don't do too much, right? I give you a quick overview of how the formula come about in a very intuitive form. All right, then we focus more on the application of the formula. All right, okay, let's try something. Right, because last sem I really explained how the entire formula comes about, but maybe by the time you all understand how the formula come about, you really doze off, or you just suck up too much energy, right? Because I think these days, wow, you all have so much social media, everyone is tired. Okay, we start off with something very interesting, very fun, and it's the simplest. All right, double integral on rectangles. Okay, this is the simplest. All right, this is the motivation. All right. Okay, this slide is our single variable. Okay, I want to link from single variable to the double integral. All right. So over here, I think, right, I just draw something out for you. This is A, this is B, right? Area under the curve. Okay, everybody should know. Integrate AB fx dx. All right. Okay, this one everybody should know, right? So given small f, find big F. Okay, so when you differentiate the big F, you get small f. Okay, when you integrate the small f, you get big F plus a constant c. Right? Okay, definite integral. Right? Okay, you have a limits a b here, fx dx, and that gives you big FB minus big FA. Where big F is what we call antiderivative of the small f. Right? If f greater than or equal to 0, then we say that this gives you the error. Right? Because error has to be a positive answer. Right? So when big F is more than or equal to 0, right, then we say that, oh, other than the value that you get, we also say it's the error under the curve fx. Okay. So all this formula, how did all this formula come about? It's always from the drawing rectangles. Start off from approximation. After approximation using rectangles, all right, and then you will see that there are a lot of lobang here, right? You can see all the lobangs. Can you see all the gaps, all the holes? Can you see? 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 All these gaps there, all these holes there. So all this originated from the theory or from approximation using rectangles. Alright? And then to make it more rigorous and more accurate and precise, exact, right? They have to invoke limits. Right? When you let n approach infinity, as infinitely many rectangles, then all the gaps go to 0. Alright, that is the derivation. And of course you have to use sigma notation and all that. Alright, okay? So this is the general formula from our single variable calculus. Alright, I'm not a bad guy lah, So the double integral, I will not set the sigma notation in the form asking you to use sigma notation. Wow, that one you will cry. Because if I ask you to use sigma notation, that means, wow, you can't use the integration. Alright, but I will go through the idea. Alright, I will go through the idea. Okay, so yes, so I think you should remember this is your height, this is your width. Alright, so height times width, that gives you the area of each rectangle. Alright, okay, our aspiration is always trying to n approach infinity. Okay, our aspiration. Alright, our aspiration. Okay, so over here is where Over here is where we set n approach infinity. Alright, okay, you can see for yourself. Okay, and then it go to exact. Alright, otherwise it's an approximation. Okay, and if f is greater than or equal to 0, the integral value is the area under the curve fx and above ab. Alright? Okay, this is the theory. I am trying to now move away from single variable into double integral. Alright? Okay? This is the theory. Okay? This time round I want to try something different. The theory will take about 4 or 5 pages. Right? I will briefly go through. Right? And then I spend more time in those actual questions, and then I show you how to apply the formula. Alright? Okay? Now, so as mentioned, alright, our aspiration is this. Okay, our aspiration is that from here, okay, I want to be able to, okay, bring you to this world. Alright? The R is the region that you are interested in. Alright? Some textbook will write this way. Okay? The R sometimes is the central here, sometimes is inside here. They are the same, depending on what textbook you use or what software you use. Okay? So don't be alarmed, okay, if you see such a thing. Okay? Okay, let's come here. Alright? First thing first. Alright? First thing first. Notation. Okay? I will give all the question in this form. This is your X. This is your Y. Okay? All the question will be in this form. Right? Okay? So, don't ask me in the exam, hey, what is that thing? What is that thing? Okay? How come got multiplication? How come AB multiply CD? No, they are not multiplication. They are telling you X is defined between A and B inclusive, and Y is defined between C and D inclusive. Alright? Okay, so this is the situation. Now, do not worry so much about how your f function looks like. F function is the one that determines the height. What you need to be very certain, sure, and confident is always your region R, the base. Okay, the base is the important one. The height, no need to worry so much. The formula that I'm going to teach you later will take care of the height for you. But the region is the one that the formula will need you to tell him. Alright? Okay? So this is the region R. Okay? Right? Because it's X is between AB. Right? Y is between CD. Right? So it's a region, rectangular region. Right? You have a Z equal to your fxy. Depending on your xy value, they have a corresponding height. Okay? Depending on your xy value, they have a corresponding height. Okay? So this is the partition R into sub-rectangles. Okay? Then you go and find the width and things like that. Alright? This one, I leave it to you. It's the same as in the single variable calculus world. Alright? Don't worry so much. Okay? Don't worry so much about all these things. Right? Okay, we always focus on a xi star and a yj star. We focus on one point, one sample point, right? And then from there we derive things. Alright? Okay, so don't worry so much. Okay, this is in your n. This is divided into m. Alright? If later you want to spend some time to read, okay, at least I set up something for you. Okay, this one there's a very minor typo. This one is a xi star and your yj star. Okay, math textbook, okay, they do all derivation using xi star and yi star. Okay, I always have this thing when students see all these star here, star there. In the end, everything you see is star. Ding, 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 like okay, like the cartoon like that. Okay, everything is star. Okay, so I don't know why. Okay, all math textbook is like that. Everything is xi star xi star yj star. Okay, Anyway, right. The most important I want to get you to appreciate here is that, all right, the volume, okay, of the rectangular box is as follow, right? Okay, is the base area. Okay, you have the base area. Okay, the base area. All right, and then this is your height. Okay, so according to your whatever x and y you are looking at, okay, you sub inside the f function. The f function is the one that always give you the height. Okay, right? Now, this gives you one rectangular block only. But now you are in x and y, right? So you are doing a for loop, right? In order to cover the entire volume here, okay, you need to sweep, okay, along the x, and you need to sweep along the y. You get what I'm trying to say? Right? It's like your computer, when you're doing simple programming, right? It's two for loop lah. Right? In order to, okay, you sweep one side only, okay, not enough. Right? You sweep like that, okay? But you need to sweep the y, okay, to get the volume. Right? Because now you need to get the volume. Alright? Okay? So that's why we have this here. Also intuitive, right? Because in the single variable world, you do one time integration, you get an error. But now you want volume. Definitely you need to do double integration. You sweep one side, sweep another side. Okay? You sweep one side, okay, cover fully. You sweep the other side is to build up the area, build up the height, so that you can get the volume. Okay. Yeah. Okay. All right. Okay. So of course the notation, right? Okay. Instead of delta x delta y, we also write delta a lah. Okay. Basically, it's the base area lah. Okay. And this gives you approximately the volume under the surface. Okay. Volume under the surface. Okay. Let's move on. Okay. Let's move on. So now, okay, as I told you, our aspiration is always n approach infinity, right? Infinitely many rectangular, the rectangular block. All right. So the double integral of your f function over the rectangular R region that you are looking at is as follow. Okay, is as follow. This is the nice notation. All right. Okay. And is equal to the previous formula, all right, but with mn approach infinity. All right. If f greater than or equal to 0, it gives the volume of a solid under the surface z equal to fxy and above the rectangular R. We also use dx dy to denote dA, right? Okay. These two usually we write it this way or this way. All right. Okay, we are trying to build up, okay? We are trying to build up the concept, all right? So, increasingly, I will try to move away from the sigma notation. The sigma notation is used for motivation purpose, right? Showing you how the mathematician 1,000 years ago, how did they come up with this formula, right? Okay. Ultimately, I want you to do double integration. Alright, I want you to do all this. Okay? Alright? Okay, now, tell me, what is the value of this integral if fxy equal to 1? This question I ask every year in the exam. What is the value of this integral if fxy equal to 1? Okay, I write out for you. Double integration of r of 1 dx dy. That gives me double integration of r dx dy. That gives you your base area is still r. Your base area is still r. Right? Your base area is still r. Okay? The base area r. But now you multiply by a height of 1. And this gives you the numerical value of area r. Okay? Give you the numerical value of area r. Right? You are still using the base area times a 1. So it's like you're still finding some sort of a volume, right? Okay, where base area times the fixed height of 1. But that is also giving you the numerical value of the area r. Right? This is a very powerful method. Okay, used at higher level, okay, for certain things, okay, that you can get away from too complicated calculation. I don't go into those applications. Now I focus more on the concepts first. All right, it's dry, right? I don't deny, but all these are essential language that you will be hearing a lot next time, right? Depending on what specialization you go to, right? So for in this case, right, because the region of R is a rectangle, so it's just b minus a multiply d minus c. Alright? Not all the cases like that. This is just an example. Alright? Because the rectangle happen, the base r happen to be a rectangle. So I can easily write out the formula like this. Okay, now I will move on to a theorem, alright, called the Fubini. Okay, called the Fubini. Alright, Fubini. Right? Okay, his theorem will save our job by a lot. Okay, Fubini formula for computation. Alright, if f is continuous in R, okay, we then have the Fubini formula. Alright? Okay, if you're interested, alright, if you're interested in this double integration, alright, you do y first, then x. Okay? Like this. Or you do x first, then y. Like this. Right? Both will give you the same answer. Alright, and I repeat again. It basically said that double integral over rectangles, rectangles, not anyhow. Okay, you must first make sure the shape is correct. Rectangles can be calculated as iterated integral. Okay, 1D integral with order. Alright, because the way you see it, okay, the way I bracket everything. Alright, this is important and crucial because it helps you see which way is easier. Sometimes if you do y first, you may get into integration by parts or whatsoever. Right? So you deliberately do x first. Then you siam away the integration by parts. Or sometimes the y first give you, wow, the integration is very easy. Right? You be able to get away from difficult integration. Right? So you must keep a lookout. Then you choose which one to do. Right? Okay. Okay, so now I give you some geometric meaning, right? Basically, we carry out the calculation in 2 steps. Okay, you view x as a constant, of course, right? That is when you integrate along y. Alright? Okay, so that is the way you write it. Okay, you integrate along y. Okay, you integrate along y. Alright? Okay, that gives you the area of cross section at x. I hope you can feel for that. Alright? Okay? Now you see, view x as a constant. You fix a x already. Okay, as a constant, you fix a x. Alright, fix a x. Okay, here. Right? And then you integrate from c to d respect to y. Okay, so now along the y, okay, is a c to d. Alright, you integrate. Alright, okay. So what you are going to get is this cross-sectional area, AX, this purple color area. Okay? Right? Because you fix the X, you fix the X. Okay, you fix the X. He will have a corresponding height according to the F formula. Right? Okay? And then you specify to integrate from Y from C to D. Right? That's why there will be many of these. Right? Many of these. Okay? There will be many of these. Okay? As you move along, you integrate along Y from C to D. Okay? There will be many coming up, many height coming up automatically. Okay? And together you look at it, it's a cross-sectional area. Alright? Then, okay? Then, right, you integrate AX, okay, from above the answer, right? You integrate AX over AB. Alright? So you integrate this respect to X. Okay? Because you do Y first, then after that you do X, Alright? Okay? Then the answer, you put it down here, you integrate respect to AB, with respect to X. Okay? Which means that this is what we want. This is what we want. Okay? It can be written in this formula. Alright? It can be written in this formula. Right? You think about it. You have already, okay, AX is the area of the cross section already. But when you do this, you integrate AX with respect to X from A to B. So this cross-sectional area, this purple color, is one piece. Now you do many of such pieces along AB. You build up many pieces. Okay, they stack up. Okay, they stack up. Right? Many of this purple one. Okay, many of this purple one. Okay, along X. Right, this is the X. Okay, from A to B. Okay, you stack up many of this purple color one. Then you form the volume. Right? Get the volume. Right? That's how double integral works. Okay? That's how double integrals work. Okay? Okay, yeah. No, they will tell you. They will tell you in the question. You give me one more minute, then we will see a real question. Okay? Now it's still the theory. Now it's still the theory. Okay? So, again, right, we have the same thing. Okay? Where we do X first, then Y. Okay? So, the formula is different. Now you do this. Okay? Integrate respect to X first. Right? Okay? Then, what we are interested in, okay? This is our objective. okay, will be this by you put inside here, okay, you integrate respect to y, cd. Okay, so the same thing, because you start off with integrating respect to x first. Okay, when you integrate respect to x, it means your y is kept as a constant. When your y is kept as constant, you see, y you kept as a constant here, right? Y you kept as a constant here, right? Okay, and then x you integrate from a to b. X you integrate from a to b. So there are many, okay, you integrate from a to b, right? So there are many here. Okay, and when you integration, that means you sum up, okay, you get this cross-sectional area. And then the second part is that you do integration of whatever you have done here, you bring it in here, you integrate respect to y from c to d. Now you integrate respect from y from c is here, to d. Many of these purple color pieces, okay, you go and, okay, many, I draw like that, in this direction. Because now it's in this direction. And then from C to D. Okay, you form them up. Okay, you form all the purple, all the slice up. You get the volume. Okay, you get the volume. Okay. Alright, so again I say this because of Fubini. Alright, you can choose the order to make the first or the inner integral easier to be computed. Alright, so to answer your classmate question, how do you determine the R? Alright, okay, is that in the question I will have this thing for you. I will mention this one. Okay, I will mention this one. Alright, I'll mention this one in the question. Then you know it's a rectangular region. Alright, and now we look at the real question. You see? Okay, I may not be so nice lah. I will say region. Alright, but you see this, you know lah. Right, you see this, you know. Okay, you see this, you know. Alright, where this is the X, this is the Y. Okay? Alright? Okay, this is your F, the height. Alright, the height. And the R is something that you must draw. You must always draw out the R. Okay? But no need to draw F. Many students do the other way around. In the exam, they draw F and never draw R. F never need to draw one. F is the height. It's a formula for the height, which the formula would automatically take care for you. But the region R need to draw out so that you can analyze. Alright? So you can use the right formula. Okay? Right? So depending which version, which direction you want to take. Okay, so imagine we want to integrate along y first. Okay, now MCQ. If I integrate along y first, which picture is correct? Integrate along y first means your x is a constant. So which one is the correct picture? Showing the correct picture. First or second? First or second? Okay. If I want to do y first. Okay. If I want to do y first. Okay, you want to integrate with respect to y first, means you keep x constant. So the ideal case, okay, is you keep the x a constant, right? Right, and then you integrate along y to get this section, this cross-sectional area. So it's number 1. Okay, number 1. All right. Okay, number 1. Okay, figure number. This is figure number 1. All right. All right. So let's go through the integration. All right, so that you have a feel. Okay, so that you have a feel. All right. You integrate along y first. Okay. So you do integration. All right. The f function you write it down, and then the dy here. Okay. When this is dy, okay, your limits will be y equal to something, y equal to something. Always write in this form. All right. Okay. So along the y, you go back and see. Y is between 0 and 1. Okay, your y is between 0 and 1. So just put in between 0 and 1. Okay, just put in between 0 and 1. Okay, integrate respect to y. Okay, 4 become 4y. X is treated as a constant, so become negative xy. Y become negative y squared over 2. Okay, then you evaluate at y equal to 1 and y equal to 0. You do your business, sub in all the y. Then you minus off, sub in all the 0. You get 7 over 2 minus x. And that's the reason why in the beginning we put a x. It means a function in terms of x, because your answer will be usually in terms of x. Right? Then next, alright, you do the second part. Okay, don't forget to do the second part. Your job is not done. Integrating along x, which will then give you the volume. Right? So you integrating along x. Okay, this part is the original question. I just copied it down. Alright? Okay, now you are integrating along x. Okay, you go back and look at the question. X is between 0 and 2. Okay, that's why I have integration of this answer put here, dx. Okay, because it's dx here, here is x equal to 0 to x equal to 2. Alright, so you integrate this one accordingly. Right, you get 7 over 2x minus x squared over 2. Bracket, evaluate them at x equal to 2, x equal to 0. You get answer 5. Okay? Okay, good. Alright, so you go back. Alright, you try the other way round and see for yourself that you will get back the same answer. Okay, see for yourself that you will get back the same answer. Alright, okay, I will do one more example. Alright, I will do one more example. Okay, then we will move on to a more exciting case. Rectangular base, very boring. What if it's a general shape? Okay, general shape. But before that, okay, I just give you one last example. Alright, boost your confidence. Alright, then we move on to the other cases. Alright. Okay, so this is the rectangle. Okay, right? So this is the x's, this is the y's. Alright? Okay, I have already written the answers here. Alright? Okay, given the f function, right? Y sine xy, right? I deliberately choose x first, then y. Alright? Because if I do y first, then x, I will have to do integration by parts. Because there are two y inside. There are y times sine xy. So if I do integration with respect to y first, I cannot run away from integration by parts. Right? That's why you must be alert. Choose the favorable one to you. Not go and tekan yourself and do the difficult one. Right? Okay? So, double integration of r, y sine xy, dx dy. Okay? I want to do respect to x first. right? I want to choose with respect to x first. Okay. Now, if you integrate y sine xy with respect to x, all the y are treated as constant. Okay, so I have a first. Okay, so this y I copy it down first. Okay, I copy it down first, the y. Okay, integrate sine xy, I get negative cosine xy. Divide by the coefficient inside, which is the y. Alright, because I'm integrating respect to x, so I divide. Right, when you do integration, the coefficient is division. Okay, right? Okay, so this is 1, 2, and this. Alright, and then outside will be 0 to pi and your dy. Okay, because your y is from 0 to pi. Now we handle inside first. We handle inside first. Okay, so the minus y over y, right, cosine xy, the y can cancel off, right? Here is x equal to 1 and x equal to 2. You sub in the x equal to 2 here, alright, and sub in x equal to 1, you minus off. Okay, and that's why I have the next line over here. Okay, I have the next line over here. Alright, I don't go and do the integration first, I go and simplify, so I get cosine y minus cosine 2y with respect to y, so dy. Okay, and then you integrate cosine y, you get sine y. Minus off, you integrate cosine 2y, you get sine 2y divided by 2. The coefficient here always divide. Okay, and then you evaluate the limits from 0 to pi, 0 to pi. Okay, you press the calculator, you will get answer 0. Remember, radian mode. Okay, in calculus, alright, okay, calculate, when you press calculator, trigo, radian mode. Okay, I hope you should know by now lah. Now, okay, this is considered basic. Alright, that's why you get answer 0. Okay, right, the full solution is also given on the next page. Right, okay, but if you do integrate y first, alright, you will have to deal with integration by parts. Okay, you have to deal with integration by parts. Okay, now we move on to the interesting case of general region. Alright, rectangular region a bit boring lah, right? How can the real world everything rectangular one? Rectangular base area, base. Right? So general region. Okay. I reflected, alright, okay. My intention is good, alright. I put in a lot of the theory, right? All this to build up the case, right? Before build up to the formula, right? But this time round, this semester, I will briefly talk about the theory only. I focus more on the formula. Okay? So basically, this is the our interested problem statement. Okay, the region D okay, is any free shape. Alright? Okay? So now we try to link it back to what we have studied in the rectangular region, so that we can come up with a new formula. Alright? So you box it in a rectangular, alright? Okay, then you make this kind of statement, right? Okay, if it's inside the domain D, right, you use the formula. If not, you put 0, because there's no actual error. Alright? Okay? Alright? So now, I want you to remember, I want not say remember, I want to be aware. Alright? I'm now going through a certain shape. Alright? What I call the type 1, okay, or what I call the X-type domain. Okay? Don't worry about all these names. I'm just following the textbook. In case some of you follow the textbook, you see all these names, then you panic or you confused or whatever. Okay, I'm just using all these names according to the textbook. Right. Also, some students prefer to see classification. Right. So I just, but in the exam, I don't. You got write the type 1 pattern or your X type pattern or whatever. I won't give you extra marks. Okay, I'm just telling you. Okay, I'm just classifying them because some students prefer to see classification type 1, type 2, type 3, type 4. Okay, right? A region D is said to be of X type if it's of this form. Okay, if it's of this form. Alright? D, a region D. Alright? Your X is between AB. Your Y is between a Y equal to some function in X and your Y in terms of some function in X. Okay? Right, where G1x and G2x are two continuous functions in X. Okay? Now, geometrically, they look like this. An X-type region lying between two lines perpendicular to X-axis and any in-between line perpendicular to the X-axis intersect the boundary of D at most twice. Okay, so basically, it's like this. Okay, basically, it's like this. Okay, you always go from the bottom to the top, 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 bottom to the top. What is the commonality here? Yes! Yes! I'm always able to go from the bottom to the top without anything in between interfering me. Yes, correct. It's what I want you to. It's what I want you to see. Okay, don't laugh, don't laugh. Okay, never mind. You laugh means you get my point. Okay, you laugh this one. Yes. So in the exam, this is exactly what you need to do. Of course, you don't need to draw so many arrows lah. You see one look, you know it's bottom to top, no interference can really. Okay, that is the whole idea. So you cannot run away, guys. You need to draw the base, right? Because you need to draw the base to see that it's of this form. Of this form, there is a special formula for this form. That's it. Right? So you cannot run away from drawing. Okay? You cannot run away from drawing. Okay? Like the first quiz, student told me that they forget the straight line equation formula. Wow, no lah. I mean, okay. Anyway, never mind. Okay? Right? So make sure you can do this. All right? Make sure you can do this. All right? Can? So, okay. This is the theory I included lah. Okay? This is the theory I included. Okay? If you have the time, you go back and read. All right? Okay? I don't want to spend too much time to go through it. All right? Basically, they are trying to link back to the rectangular region and then trying to form a formula from there. Okay? But you go back and read it. Okay? We can state the formula immediately as well. Okay? Now, every time you have identified is the X type. Okay? You want to compute the double integral on the X type. Where? Okay? You already know this. You draw out already and make sure that, okay, there is, okay, you draw and make sure that there is no issues. Right? So what do I mean by issues? Okay? Maybe let me give you one case. Let me give you a negative example. I give you all the beautiful example. I never give you the negative example. Cannot, right? Right. So imagine this case, A, B. Okay, we have some shape like this. Okay, I just anyhow draw lah. I just anyhow draw accelerated accelerated. Okay, so this is your G1x. This is your G2x. Right. So this one cannot right? Bottom to top, bottom to top, bottom to top, bottom to top, bottom to top. Nah. Okay, cannot. Okay, so you cannot apply the formula for the whole domain A to B. Alright? Okay, so okay, alright? Okay, so now, okay, I state the formula. If you have this X type, the formula is as follow. Okay, you do the integration. Alright, fxy dy inside first. You must do it by this way first, where your y is equal to this, your y equal to this. Okay, after you finish doing the integration inside already, okay, then you do outside respect to x from A to B based on the yellow color definition you have. Okay, the only order allowed is y first, then x. Okay, and of course, if f equal to 1, it gives you the numerical value. Okay, it gives you the numerical value. Okay, it gives you the numerical value of the area of the base region. Right? Okay, if you change the f to 1. Okay, if you change the f to 1. Alright? Now, I think I show you one example, right? And you'll be very clear after that. Okay, I show you one example. Okay, you'll be very clear after that. Okay, so for such case, alright, we do the integration of the y first. Alright? Okay? So this is y equal to this, y equal to this. Right? Because you do the y, you see, you do the y first, integration. That means you do this. Bottom to top, 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 bottom to top. Okay? You sweep this one. Sweep all of them first. Right? Okay? Then you do the outside with respect to x. This way, you sweep up the volume. Okay? Now you are looking at the top view like that. This is the base. Okay? So you do the first part. You only get the inside that piece. Okay? You sweep up. Okay? You only get the inside the piece. I do the last one, integrate respect to x. Okay? I sweep it up, out. Okay? So it's x, y. Your z, which is your height, is coming out. You get a volume. Okay? Right? Okay? This is the only way for this type. The only formula. Okay. Now, let's move on, okay, to discuss carefully all the small little points. All the small little points. Okay, knowing the formula is just one thing. Now is the application. Okay, application. Alright, now is the application. So for this question, okay, we know that the region R is enclosed by x plus y equal to 1. Okay, and x squared plus y squared equal to 1. Alright? Okay, enclose, enclose. Okay, so you know that your R is x plus y equal to 1. That gives us y equal to 1 minus x. Alright? Okay. And what other information do you have? Okay, what other information do you have? Okay. Your R is actually... Okay, you see, guys, you see, I deliberately do like this. You see, I write down all the information. I cannot get anywhere. I cannot get anywhere. You see, I write here, right there. Alright, still get back y equal to 1 minus x. So what? Okay? Because this kind of question, you cannot run away from sketching. Alright? As I mentioned, you don't have to sketch the f function. That one is always very complicated and is automatically incorporated into by the formula, so you don't have to worry. Your main worry should be the other one. Okay, so let's draw it. Did I draw? Draw it. Right, okay. Right. Guess my drawing is, when I do real time, is not so nice. So I always try to draw in advance first. Okay? So x plus y equal to 1, y equal to 1 minus x, okay, is a straight line graph. Okay? No question, no problem. Everybody okay, happy. Right? X squared plus y squared equal to 1 squared. That is a unit circle, right? Radius 1. Alright, unit circle radius 1. Okay, you draw. Right, unit circle radius 1. Alright, unit circle radius 1. Okay, but there are some working involved. Alright, y squared will be equal to 1 minus x squared. Y will be equal to, okay, if you do by your algebra, your y will be equal to plus minus square root of 1 minus x squared. Okay, because I'm focusing on this portion. Okay, I'm focusing on this portion. Right, I change the y to positive square root 1 minus x squared. The y value is a positive answer. Alright, because it's the first quadrant. Alright, what we call the first quadrant. Okay, this part here, okay, is the first quadrant. This part here is the first quadrant. Alright, okay, so we know that R is x plus y equal to 1, where y is equal to 1 minus x, which I draw the red color line already. And then, because he said enclosed by the line and enclosed by the unit circle, that means must be this portion here. And this portion here, bottom to top, bottom to top, bottom to top, bottom to top. Therefore, this you can conclude that R is of the X type. Okay, R is of X type. Where X, okay, you can tell that from here the X value is always between 0 to 1. Alright? And how about your Y? Your Y is defined by the bottom by a straight line, where the Y function is Y equal to 1 minus X. So you write 1 minus X here. Alright? And the top part of this curve is Y equal to positive square root 1 minus X squared. Okay? You have all the essential setup already. Alright? You have all the essential setup already. Alright? Which is, okay, all these are the explanation. Alright? You can go back and read it carefully. Okay? I have more elaboration in the notes. Alright? Okay, you can see this one. I like to draw this bottom to top, bottom to top, bottom to top, bottom to top. Alright? Okay? And then here, okay, I want you to take note. Okay? To enclose the shaded region, okay, your x value, the smaller possible x is x equal to 0, and the largest possible x is x equal to 1. Alright? Okay? And again, right, similarly, you have this, okay, the bottom, the most bottom is at y equal to 1 minus x, and the top is y equal to square root 1 minus x squared. Okay, and therefore, you apply the formula, right? Apply the formula that I have been mentioning here. This formula, you apply it exactly once you identify it's the x type and the limits, you apply it here. The f in this question, I did not give you. Just leave it at f. Okay? Must always be dy, and the y, the bottom, most bottom, is y equal to 1 minus x to y equal to square root 1 minus x squared. And the most outside, okay, your x here controlling is from the lowest possible 0 to 1. Then you do your double integration. Bingo. Alright? Okay. Okay, this is so that it includes, okay, so that it includes everything. Okay, and let's wrap up. Okay, let's wrap up with this section. All right, they say that, hey, I just want to find the base area, the area, okay, the area of R. Okay, I just want to find the area of R. Okay, the area of R means that F is 1. Okay, the numerical value of the area of R, just take F as 1. Okay, you take F as 1. So 1 here, 1 here. Alright? Okay, and you integrate 1 with respect to y. Of course, you get y. Okay, you integrate 1 with respect to y, you get y. You get y, but the limits are here to here. So you put in the top limit minus of the bottom limit. Alright, and then you integrate with respect to x. This one, difficult lah, huh? Okay, there is a special formula for this pattern. Okay, you let a equal to 1. Okay, you let a equal to 1, you sub in a equal to 1 here. Okay, arcshine. Okay, you do the integration, you get arcshine. Okay, so you write down the formula accordingly. X over 2, replace the a by 1. Okay, and replace the a by 1, and this part. Alright, but this one can integrate easily. Negative minus 1 minus x, so you get negative. Then you get a negative x. Then negative, so become positive x squared over 2. And don't forget, okay, sometimes students very careless. Your x equal to 1 and x equal to 0. So evaluate the limits. Sub in all the x equal to 0 and sub in the x equal to 1. Upper limit, evaluate, minus of, sub in the limit of x equal to 0. Press calculator. Arcshine, okay, you gradient book. Okay, you get this answer. This complete the solution. Guys, you all have been wonderful. Alright, please take a 5 minutes break. Okay, okay, actually today I thinking of eating your 5 minutes break one, but I very guilty because I see you all putting so much effort to listen already, then I still eat your 5 minutes break. I feel bad. Okay, I feel bad lah. Usually I give at 1:30. I give at 1:30. So I don't eat 5 minutes. Those 5 minutes can do a lot lah. Okay, but no lah. I feel bad. You go for your break. Okay, just take a break. Okay, just go and take a nap or whatever. Okay, then the rest you go washroom. You go washroom. Okay, just go and take a break. Okay, take a break. Alright, can? Yeah, come back in 5 minutes time. I just finished. We finished marking the quiz one already. All right, we finished marking the quiz one already. Okay, my apology. I have not uploaded the score yet. Okay, I will return it to you in the coming Monday tutorial. Okay, thank you. Yeah. Okay, take a break lah. Take a break because a lot of new concept today. Okay, take a break. Okay, refresh, rewind, recharge. Okay, then I'm going to go through one more new concept. Okay, but before that, let me set the limit. Let me set the break. Yeah, usually we break 20 minutes. Wait, how to set the timer? Okay, I set the timer already. Okay, guys, yeah, yes, come, yeah. Yeah.
Then can we just use the regular stereo shaper? To get credit we still need to go through.
Because sometimes I set the question with all this in mind.
Or will there be like questions where
Okay, okay. Okay, let's come back. So, okay, so we went through, yeah, we just stopped. We just ended here, right? We just ended here, all right? So there's one last example, okay? There's one last example to wrap up, okay, this segment, all right? Okay, over here, okay? So this is D, all right? Is D or R lah? Huh? Usually my question, D or R. So now they tell you that D is a region bounded by the parabola y equal to 2x squared and y equal to 1 plus x squared. Oh yeah, guys, before I forget, okay? Before I forget, okay? All these questions that I gone through with you, okay? With you, in the first step, in your first working, is always what? It's always, yes, sketch the graph. After that, or okay, actually before even sketching the graph, what is the first thing you must do? Just now I didn't mention because it's a good habit lah. It's a best practice, right? But I'm just worried you don't do it. Tell me, before you sketch the graph, what do you do? Before you sketch two graphs, what do you do? Okay. I also don't know how to spell. Wait lah. How come so long one? Okay, come. E. E have to buy. E is a vowel. You have to buy a vowel. Okay. Okay. Sorry? Sorry? Hey, before you sketch two graphs, what is the first thing you do? Before you sketch the two graphs, every one of you will be doing that one. Don't tell me. Huh? Correct. Okay, I meant it as simultaneous equation. Okay, wait S-I-M. Simulate. Anyway. Okay, anyway, you do simultaneous equation first, okay? Because you need to do simultaneous equation, you equate the two expression, then you solve. Because you need to get the common point of intersection. Without the common point of intersection, you cannot draw one. You draw already, everything also not accurate. Alright? And then that you will have difficulty of the x limit also. Those limits. Right? I didn't do the simultaneous equation part because all these questions are quite intuitive. Okay, in my mind I already worked out the points of intersection already. All right, so simultaneous equation, I leave it to you, this kind of thing. Okay, all right, okay. So you do the simultaneous equation, all right, and then you have to sketch the graph of y equal to 2x squared, all right, and sketch the graph of y equal to 1 plus x squared. Okay, I leave it to you to sketch the graph. Okay, this time round is important to sketch to find the simultaneous equation, to find the points of intersection. Otherwise, you don't know this one. You don't know this one. And if you don't know these two, you cannot get this one and this one. Okay? Alright? And then please label your graph. Because these are all the limits in your double integration from bottom to top. All right, for bottom to top. Okay, so from this graph, after you sketch out everything beautifully already, okay, you do the testing. All right, can you go from bottom to top, bottom to top, bottom to top, bottom to top, bottom to top? Yes. Right. Then after that, you write out this line for me. This one you fill in the blank on your own. Okay, right? You know it's of the X type lah, huh? Because after you draw out, you know it's of the X type. Okay, right? Your Y is between the bottom, Y equal to 2x squared, to the top graph is Y equal to 1 plus x squared. The X is between negative 1 to 1, covering everything. Okay, covering everything. Okay? Okay, then you do your double integration. Alright? It's a fixed formula. Okay? So this is the generic formula. Okay, generic formula. Alright, I will not give you marks for writing down this one. Alright, okay. Of course, the only formula for the X type is this formula here. Alright? So you do your integration. Okay, you do your integration. I will just read lah, huh? Okay, you do your integration. Alright, x plus 2y respect to y. So x is just a constant, so you become xy. 2y become 2y squared over 2, so it become y squared. Okay, then you evaluate it at the lowest here is 2x squared, the top here is the y. You sub in, you replace all the y with all the top and bottom limit, then you minus off. Okay, you minus off. So everything is written out nicely for you. I usually type out everything nicely for you already, right? Okay, and then you simplify. Okay, simplify. Okay, and then now you move on to the last one, dx with respect to x equal to negative 1 and x equal to 1. Alright, so you do your integration, you get all these things, then evaluate it accordingly. You get 32 over 15. I urge you, go back, spend 5 minutes, do this question out on your own to make sure you can get the same answer as me. Right? This ends the solutions. Okay, this is the second type. Okay, you have the first X type already, the pattern. I believe in your mind, okay, you are also hoping to see the Y type. Right? So that it form a complete picture. Right? So the Y type, okay, right, the Y type region lies between two lines perpendicular to the y-axis, and any in-between line perpendicular to the y-axis intersect the boundary of D at most 2 times. Right? So you can see, right, okay, from the left to the right, 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 from the left to the right. Okay, likewise, okay, over here, from the left to the right, 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 from the left to the right. Okay, everything, no interference, nothing in between to interfere. Alright, okay, everything smoothly. Okay, and of course, now all these functions, okay, now all these function will be in terms of x equal to something, x equal to something, x equal to something, x equal to something. Okay, so when we try to formulate the problem, okay, your y is between a C and a D. Okay, number. Right? But your x is always between, okay, x equal to a function in terms of y, in lower, the left, not lower, the left boundary, and the right boundary is the h2y. Okay, another function in terms of y. Alright? Okay, so you sweep here, sweep here, sweep here, sweep here, sweep here. Left to right, you sweep. Okay, you get the area of this already. Right? And then you sweep from C to D. Form the volume up. Okay? Alright, this is the clean picture, which I will also put it in the slide in the solution. Right? In case people don't like to see my wording. Okay, so everything is here. Alright? And then okay, so after you determine that it's a Y type, okay, then you can write out all these things. After you can write out all these things, right? Then it come with this formula. Okay, then it come with this formula. Okay, then it come with this formula. Right? It's a fixed formula, alright, where you do the only order is x first, then y. Okay, this is for the y type. Okay, this is for the y type. Okay, this is for the y type. Okay, then you use this formula. Okay, so let's do one example together. Okay, find the volume of the solid that lie under the paraboloid of z equal to x squared plus y squared. Now, the z is the f function. No need to care how he looks like. Okay, the z is always very complicated and difficult and complicated looking one. So some students see the z function very ugly, they give up the question. No, right? Z is taken care of by the formula one. Don't worry. Your job is to focus on the region, right? Find the volume of the solid that lie under the paraboloid z equal to x squared plus y squared. That is the height. That determines the height formula. And above the region D, yes, your job is to focus on the region D in the xy plane bounded by the line y equal to 2x and the parabola y equal to x squared. Alright, you go and solve first. Okay, you go and solve first. This time round, if you don't solve, you cannot draw. Right, so you equate y equal to 2x and y equal to x squared. So you equate them together, 2x equal to x squared. Please guys, don't tell me cancel. This one is Sec 2, we always scold the student one, right? Don't, simultaneous equation cannot cancel anything one, right? You bring over, so x squared minus 2x equal to 0. X is x minus 2 equal to 0. X equal to 0 or x equal to 2. If you cancel, you lose the x equal to 0 straight away. Right, Sec 2, we always scold the kids, right? Remember? Okay, right? They always forget this thing. Okay? So, you know the intersection already. You go and draw the graph. Okay? You go and draw the graph. Alright? So, okay? I draw two versions for you. Alright, I draw two versions for you. Okay? Of course, once you know the x value, you can find the y value. So the y will be equal to 2 times 0 is 0. Y is 2 times 2 is 4. Right? That's why I have the intersection at 0, 0 and 2, 4. 0, 0 and 2, 4. I put in the notes two figures so that you can play around. This question is flexible. You can use x or y. Okay? You can use x or y. But our purpose is to demonstrate the y. So we do the y. Okay? So for this question, right, we do the y. That means we do from left to right. Okay, so you test it out. Left to right, okay, left to right, okay, left to right, okay, left to right, okay, left to right, okay. Beautiful, marvelous, right? Okay, so we can do the y type. Okay, so you do the y type. You must tell me what is the bottom curve. The bottom curve is, how come I keep saying bottom curve? Y type is left to right. So you must tell me left curve and the right curve. Not bottom to top. Okay? For the y type, it's always the left one to the right one. So what is the left one? What is the formula for the left? The formula for the left is x equal to y over 2. Okay? You have to make x a subject. Right? That's why I have two similar curves, but one is in terms of y, one in terms of x, to show you. So you make x in terms of y over 2. What is the right curve? The right hand side curve. The right hand side curve is x equal to square root y. Okay? X equal to square root y. Alright? And your y value is bounded between 0 to 4. That's it. You have everything you need for the y type. Okay, so remember, Y type is from left to right. Okay, that's why you identify the left curve, okay, and the right curve. Okay, in this line, in this case, it's a line. The left one is a line, the right one is a curve. Okay, so you have this. These are the essential. You already got the essential already. All right, you already got the essential. Okay, right. So for the same curve, for the same situation, if you are going this way, you can see I keep it in term. Okay, I keep it in term of y. Okay, it's for the formula, right? It's for the formula. Okay, so here, right? I want to treat it as a y type. Okay, so I'm looking at this case. Okay, I'm looking at this case. All right. Then you apply the formula. Okay, this is the f function. Okay, inside must be a dx. Okay, inside must be a dx. So this is x equal to y over 2. This is x equal to square root y. Okay, usually I will write a small here. I will write a small x equal to this. X equal to this. To remind myself and to check. Make sure I'm not making any stupid mistake. Right? So here is x. dx, you say x equal to this, x equal to this. Okay, then you do your integration. Alright, so integrating respect to x. Okay, then your dy outside from 0 to 4. So x squared, you integrate, become x cubed over 3. Y squared is, y is just a constant. So it become y squared, attach an x. Okay, evaluate it. Okay, put in the x equal to y over 2, x equal to square root y, you do your business, whatever, okay, all these things I leave it to you, go back and do on your own, right? After that, everything you simplify, then you do the integration, okay, with respect to y, you do as per normal, sub in the limits 0 to 4, you get 216 over 35. Please go back, spend the 5 minutes to do. This one will not take you more than 5 minutes, okay, to do this part. Right, I already do the setup for you already. Okay, this part is mechanical, you do it. Alright? Okay, you may also attempt to treat it as an x type. Okay, do everything out, you will get the same answer. Okay. Today we must celebrate. Okay, I finish before 2:30. Okay, I finish before 2:30. Alright, okay. Oh, I'm so happy. Okay, and then I also give you a break. Alright, and then you all be very, very attentive. Thank you so much. Okay, today is the best lesson. Right, because I see everybody really, right, I know I saw a few dozing off, but quickly they quickly, no, feel, a bit okay just for 1-2 seconds, 1-2 seconds, okay, because I see everybody face like that, I can see. Right, thanks for the time, thanks for the time, okay, good, okay, no, can go already, no worries. Okay, I like to talk. So okay, the next quiz is in I put it at week number 8. The reason is because so that you won't be so stressed. Okay, you have the whole midterm break to go and study. Don't tell me you still stressed or whatever. Okay, I put week 8. Alright, but later a bit cramped, right? Because the other quiz will be close to the end of the sem. Alright, okay, but never mind, it should be okay, right? Okay, that's all for today. Thank you for your time. Okay, so these are the things we have completed. Okay, thank you so much. All right, thanks.